Hi, this is the third video in our series on naming of organic compounds. This series of videos is used in collaboration with the CAPS document Grade 12 Physical Science. In our previous two videos, we looked at how to name alkenes, alkanes, alkynes in the first video, and then haloalkanes and alcohols in the second video. In this video, we continue with the homology series, and we are going to look at the aldehydes as well as the ketones. So how do we recognize them? With the aldehydes, at the end of a carbon chain, you will always find a double bond O and an H connected to the carbon. The aldehydes end in L. Examples of this include methanol, ethanol, pentanol, and so on. The ketones are very similar. For the ketones, we also have a double bond O that is connected to the carbons, but in this case, the double bond O must be connected to the middle of a carbon chain, or somewhere that is not in the end. If I have 5 carbons, it can be connected to the second one, or the third one, and the ketones will end in -one. Examples of ketones will be propanone, or butone, and so forth. Let's quickly look at them in examples. With the aldehydes, you can see here is my carbon chain, and at the end of the carbon chain, I have a double bond O. Let's look at this one that is slightly more complicated. There is my longest carbon chain. Can you see in this one I've got several carbon chains? I've got one going down here. I've got another carbon chain going down there. I can view this as a carbon chain. I can view this as a carbon chain. A carbon chain is just where carbons are connected to each other. When I name my organic compounds, I always look for the carbon chain to which the functional group is connected. In this case, it will be this one. Can you see that is my main chain? And with this one right at the end, I have my double bond O, which makes this an aldehyde. Let's quickly see how we're going to name these two aldehydes. This one over here is going to have the name ethanol, ending with Al. And this one over here will have the name 2,2-dimethyl butanol, ending with the Al again. Okay, so the next group is my ketones. Again, I have my double bond O, but can you see now it is connected to the middle of the carbon chain? This carbon chain looks a little bit different than this one, where I have the little lines between the carbons. I deliberately did it this way so that you can see there are more than one ways of writing these. We'll get to that a bit later when we do the theory. Okay, so here we see we have our main carbon chain, and in the middle of this one, I have a double bond O connected to this one. Now look at this interesting example. It appears as if this double bond O actually sits on the end, but it doesn't. If you look at the carbon chain, although it's bended, all of these still form one chain. The one chain or carbon chain will go all the way up to the last carbon that is connected to it. So let's look at the name of these two ketones. This one over here is called heptane 4-one. So as you can see, the -one ending for my ketones. And this one over here is called propanone. Okay, so by now you should be able to identify alkanes, alkenes, alkynes, alcohols, haloalkanes, aldehydes, and ketones. As I did in the previous exercise, let's mix up all these different homologous series and see if you are able to identify them either from their structures or from their names. Good luck!